week we talked about exponential functions, and logarithm and exponential functions go together. Today we're going to learn what is a logarithm. I spelled logarithms wrong. How logarithms are the inverse of an exponential function, and then tomorrow we're going to graph. So today we're not graphing. That's good, right? No. I wrote these notes after Pi Day. Like I stayed after school on Friday and wrote these notes. So let's see how ridiculous they are, because I kind of ate a whole lot of sugar on Friday. So, and same 7 times in a row. So it's kind of ridiculous. I do, but so do the other teachers. But like when I have prep, they have a class. So, but we did record it. You don't really have to write this down. Just write the section if you haven't already written it. But on 7th hour, they both had really small classes, and we just recorded in 6th hour. So we just did the rap for them, and then we made them just watch the video. But all 7th hour, I could just hear Pi Day, coming from Ms. By's room because she had the volume up so loud. And so I just kept hearing it over and over and over. It is on YouTube. So.
My sister thought they were active.
Mr. Ricky, which none of you know, but he used to work here, and he commented on my video that this is just awful, but also awesome. So yeah, it's pretty awesome.
It was great.
What? The one I go grab something with, yes. That the kids think is inappropriate, but it's not. Yes. Yes, he changed his picture on Facebook to Pi Day, so he's a funny guy. All right, just to remind you, inverse functions are what undo another operation. So what's the inverse of addition? Subtraction. What's the inverse of multiplication? Division. What's the inverse of squaring something? Square rooting. So what's the inverse of an exponential function? A logarithmic. It has a little a in there. Logarithmic. And your book talks about that the inverse of an exponential function is so important that it gets its own name. I think that's a little silly. But when we're talking about logarithms, remember that it's just an exponential function. So the next slide here, I have kind of the definition of a logarithm, and then we'll talk about what that means. Okay, and again, you can write this down, but you don't really have to. I want you to write down, though. There's lots of restrictions on logarithms. So x has to be greater than 0, and a has to be greater than 0, but not equal to 1. It could be a fraction, a positive fraction, right? It could be bigger than 1 also, it just can't equal 1. So it's not just between 0 and 1, it's just bigger than 0 and also not equal to 1. Oh, it's a little a. Remember with logarithms we have a base down here, so like I would, if I was writing this, I would write it like this, just an a. And if and only if means that it's true both ways. So if y equals log a of x, or log base a of x is how we say that, then that means x equals a to the y. If you know this is true, then this is true. Part of your homework today is just practicing going from log form to exponential form, from exponential form to log form. Basically, a logarithm is just another way of writing an exponential problem, which means we can say that a logarithm is really just an exponent. In my pre-calculus class, I don't know if in Algebra 2, I kind of forget that test. Mr. McClure has it. You guys have to tell me. But on my pre-calculus test, there's a question on it that says, a logarithm is a what? A blank? And people always write things like torture and death. But really, a logarithm is an exponent. Because when you rewrite a logarithm, the base goes here. This is your answer, and the answer to a logarithm is the exponent that makes that true. And mostly we just got to get our brains back to thinking of when we see a logarithm, what it's asking us to do. So part of your homework today, these are the directions in your homework. It says change each exponential statement to an equivalent statement involving a logarithm. I don't know that you need to write all those directions down. You could just put change to logarithm if you want to shorten that up. If they're just going to give you problems like this, so I'll give you a minute in case you're in those directions. So. asking you to do. They're asking you to change it from this to make it look like a logarithm. So it's just kind of practicing what goes where. So the exponent is always what it equals. So if I was rewriting this, I would say 3 equals. And I always remember the base of the number is the base of the logarithm. So this is the base. So that would be log of 1.2. And the answer becomes what goes with the logarithm. So 1.2 to the third equals m is the same as saying 3 equals log of 1.2 of m. There's nothing to solve on that. So you do this one. And don't I guess you could put equals 3 on the other side if you want. This is my base, so I could write it this way. Log A of 24 equals the answer is the exponent 4. Oh, look, that's it on that one. I thought there was a third one. You with me on that? I just switched it around this time. But the exponent is still my answer. This part goes here. The base goes as the base. Log A of 24 equals 4. Did you write that? Okay.
I just wrote it the same.
Oh, yeah. I was just throwing it. The equal sign could be on either side. Just trying to show you that it doesn't matter. Okay. What if we go the other way? What if I asked you to change it from a logarithm to exponential? And probably that's what you're going to do more when we actually evaluate these. A lot of people work better if we change it to exponential. But we'll see. And again, it's just remembering what goes where. The base is still the base. Remember that the answer to a logarithm is an exponent, which means the other number that you write there is what goes on the other side of the equal sign. So remember that it's a to the y equals x is what we're thinking of. So we could say a to the 5 equals 4. This is your base. That's your exponent. That's what's go on the other side of the equal sign. And again, it's just kind of getting you back to remembering that. I'm going to have to open the window again. This is getting hot. It's going to shut down in a minute. In first hour it said, the projector has overheated, and it just shut off. So I'm going to freeze you in a second. This one would be 3 to the c equals 5. Because I can feel the heat. I know. Miss Vise does this like every day, so mine's just started. I'm so thankful for it. No, they say that there's nothing they can do because the heat comes out of the air and it comes straight over, and that you just got to deal with it. I'll put a fan right here and just blow it up there so then I have to talk even louder. That'll be awesome. The other part of your homework is actually finding the value of these, which means if you know how to rewrite it, then you should be able to do this. Find the exact value means that you should be able to do this without a calculator. And once we do this a few times, you might not even need to rewrite it every time, but I'm okay if you do. Goodness, there's so many. So, Sawyer, stay away from that calculator for a second there, buddy. No calculator. This is like saying, if you rewrite it, right, if you want to think about this as a y over here, you don't have to, but this is like saying 2 to the what, or 2 to the y equals 64. And then you have to say, what? I have to know those powers of 2? But you really could work that out, right? I know 2 to the 5th is 32. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Which means if I multiply by 2 again, then I would get 64. Which means the answer to this, what exponent, 2 to the what equals 64, the answer would be 6. What? don't have a log button that you can type in besides log base 10, except for cheating calculators. If you have a calculator that has a log base whatever, then you're not going to be using that on your test. Just so you know. But on most calculators, we might get to this in a minute. I don't remember if that's today or not. Log base 10 is called common log, and that's the button that's on your calculator, not log base 2. What about this one? This is like saying 7 to the what equals 1. What's the answer to that? Would log base anything to 1 always be 0? Because it would say whatever the base is to the what equals 0, and only something to the 0 power. So that's one that's kind of nice to know. What if... Looks like a donut. What about this one? I just want to caution you to not just put 2 here, because a lot of people are going to look at this and say, oh, 5 squared is 25, but pay attention to how you would rewrite this. If this is the base, this is like saying 25 to the what equals 5, which means you have to think about 25 to what power is going to equal 5. Fractional powers are like roots, right? So Kelly says the answer here is 1/2, because the 1/2 power is the same as a square root. 1/3 power is the same as a cube root. So remember that fractional exponents are like roots. And then, what about a problem like this? Stop. You don't need a calculator still. So I'm going to take that calculator and throw it on the ground. I took a calculator from Zane last week, only with my own calculator, and I threw it into the, like, I just threw it up towards the floor. Yeah. What about on this one? How do I take a power of 10 and make it a fraction? What kind of exponent am I going to need? Negative exponents give you fractions. So I just wanted to remind you of that because some of those are on there. And this would be like, you could rewrite this as like 10 to the what, and then you could rewrite 100 as 10 to the -2 if you want. And then you'd be like, oh, the answer is -2. Right? I don't know how you get that, but it's -2. Or you could be like Sawyer and just rely on your calculator too much and type it in. But you're right, you could because it's a 10.
And on test, you'll make sure you get it right.
Questions about that? There's nothing in this for trash can. Oh look, this one's for your calculator, Sawyer. Notice there's nothing written here. Alright, when you see log of x, that's the same as log base 10 of x. We don't put the 10 there because we are a base 10 number system. We call that the common log. And if you find a log button on your calculator, you'll notice there's no base there because it's log base 10. And there are a couple on your homework today that they just want me to type in the calculator. And so I thought maybe we could just practice this and make sure that we could do this. Anyone else get a calculator? They want a calculator? Bryce, want a calculator? Ready? Oh my goodness, it does, but not for 7, right? If you do log base 7, that's like saying 10 to the what power equals 7. Not a pretty number, which is why we need a calculator. You should get like 0.845, and it keeps going on forever. But when you type in log -2, Sawyer says domain error, and think about what that's asking you. That's asking you 10 to the what power equals -2. Can you type in a number to take 10 to the power of to ever get a negative number? Think about our exponential functions. They always had a horizontal asymptote because you couldn't get a negative number, right? You can't take the log of a negative number. There's no exponent that will ever give you a negative, which is why it doesn't exist. You could say no solution. You could say undefined. I'm going to say undefined, I think. I like that one better. Not possible. Domain error. 0 with a slash through it. I don't know. All those would be acceptable, I think. No with the exclamation mark. What haven't we talked about? Our good buddy E. Oh wait, I gotta do these properties first. I told you there's a lot of notes today. Right. You can't do it. 10 to the what power equals -2. You can't plug in an exponent and ever get a negative out of it. You can't even ever get 0 out of it, which is why when we graphed exponential functions, they had a horizontal asymptote at 0, because there's no number that you can plug in that will ever equal 0. You'll keep getting fractions smaller and smaller, but they'll never be 0, they'll never be negative. And we'll come back to that again, but can't do it. All right, we're going to solve equations eventually with logarithms, just like we did with exponential functions, but there's just some properties that are always true with logarithms. And again, if you want to know where these come from, think about rewriting them. This is like saying a to the what equals 1. We just talked about that. That's always going to be 0, no matter what the base is. If you take the log of base anything of 1, it's going to be 0. What if you took the log of base a of a? That's like saying a to the what equals a. It's always going to be 1. Do you have to know those? No. You could just rewrite them and figure them out, but they're just nice ones to know. Here's what's super great. Exponential and logarithms are inverses. So just like a square root cancels out a square, a cube root cancels out a cube, addition cancels out subtraction. If you have log of a to the x, because that's an exponential in a logarithm, they just cancel each other out, and you just get x back. And it's the same way if you did it the other way. If you had an exponential function with a logarithm up in the exponent part, so that's a raised to the log a power, just like an x squared and a square root cancel each other out, those cancel each other out. Very nice when we solve equations, which we'll do later in the week. Not today. And then, just like we talked about, if you have two exponents that are, or two bases that are the same, that you can set the exponents to each other. If you have log base a of x equals log base a of y, if the logarithm bases are the same, then we can say that we know that just x equals y. Which means some of the problems you do today, you might be able to use these properties. Again, because we're not solving equations today, you could just rewrite them all as exponential form and be able to figure them out. The last thing I want to talk about is e, because when you take the inverse of e, it's a special logarithm. We don't say log base e, right? You remember what we say? It's a button on a calculator right next to log. ln. E is called the natural exponential number. The log base e is called the natural logarithmic function. And we don't ever write log base e because e is a number that's always, goes on forever. We say that's ln of x. So log base e is the same as ln. Why don't they say nl? I don't know. But we say ln. And there's a button on your calculator because ln is always base e. So you're going to see that we're going to save these same properties that we just did with logarithms, we can say with ln's. When I write ln, I always use a cursive L, because notice here, if you use a print L, what does it look like? It looks like a 1, and so just be careful with your writing, because you might be like, 1n, where did this come from? So this is why you need to learn cursive in school, so you can write ln.
I agree.
It's true. That's not very nice. log of 1, right? And we said log base anything of 1 will always be 0, but again, it's because e to the what equals 1, e to the 0. ln of e, that's like saying e to the what equals e. What would you say? 1. Or again, it's log base e of e, so they cancel each other out. And just like log of x and a to the x are inverses, ln and e are inverses. So if you have ln of e to the x, again, they cancel each other out. Super great for solving equations. My x is seem very weird today. And if ln of x equals ln of y, then what do you think is true? X equals y. So on these problems with ln and e, I know there's you have a calculator, but the idea is I want you to use these properties without a calculator. That should say 1 over e. I don't know why my e is a little. There's no hope for it. I know there's a lot of examples today. That's supposed to say ln of 1 over e. 1 over e. Here, I'll rewrite it. ln of 1 over e. Stop with your calculator. I'm going to throw it in the trash for real. Can I rewrite this so it's ln of e to a power? What would be the power if it's 1 over e? E to the negative 1. Look up here. ln of e to something is just that something, which means what's the answer to this problem? It's just negative 1. Would your calculator give you that? Yes. But what if I don't let you have the calculator? Which there's a good chance I won't. What? Use the same idea on number 12 as number 11. Can you rewrite that as a power? And if you can, ln of e to a power will always just be that answer. The power will be the answer. What's the power for square root? 1/2, right? 2 is squared. This would be like ln of e to the 1/2, which means the answer is just 1/2. I should have started with this one. Like backwards. 7,641. Sure. What's the answer to this one? What if I asked you to type this in your calculator? Again, it's just wanting you to practice where the button is on your calculator, and I think maybe, I don't even know if I did an example of this. I might have deleted it because I was like, you can do this on your calculator. But next to the log button, or somewhere near the log button, there should be an ln button that you can just type in and get decimal answers. So let's see if I have the example of it. Oh no, I don't even have one. But there's going to be that on your homework too. This is 6-4 day 1. I want you to do 9 through 24 multiples of 3. The first ones are just write it in log form, write it in exponential form, and then it's working out, like find the exact value. Tomorrow we're going to look at the graphs of these and see how they compare to exponential graphs, and we're going to actually graph them. And then Wednesday, I'm not going to be here Wednesday, but I'm going to a field trip with Parker to the Children's Museum. But I'm probably going to record some notes for you of solving these equations. And then Thursday, we're going to do a worksheet reviewing both. Scott. No. They only could take 10 parents. It was very. Well, we're not